Our colleague Silver Traat, who is a co-founder and COO of a company Texta, which is part of this project, will present an EMBEDDIA Media Assistant and Texta Toolkit. So, Silver, the floor is yours.
Hello, my name is Silver Traat. I'm the co-founder of Texta, and I will give you a presentation about the EMBEDDIA Media Assistant. But before I go to that, a few words about Texta. We started doing research in natural language processing all the way back in 2014. We were asked to analyze some digital health records here in Estonia, and we found that the existing tools were language dependent, they didn't handle big data, or they were domain specific. So we started working on it, and in 2017, me and my co-founder Raul, we founded the company. Since then, we have executed more than 40 successful natural language processing projects for media houses, for public sector, for big companies, and so on. We have grown to a team of 10, consisting of developers and data scientists. We have classified or tagged more than 1 million articles since then. During the last year, we also moderated over 10 million comments. And the tool that we have created is the first artificial intelligence software that was added to the Estonian state code repository. Next, I will show you, my presentation will be divided into two. First, I will show where you can find all the tools and what you can do with them. And second part will be about the Texta Toolkit, where I will show you how it can be used from an investigative journalist point of view or a data scientist point of view. I will show you the website now. So if you go to embedded.texta.ee, this is where we have gathered all the tools. We give an explanation about the solution, some technology description behind the tools that we have created, and the different access points. The different access points that we have created, there are actually 4 different kinds. Firstly, we have a Docker registry, so anybody familiar with Docker, some of the tools are Dockerized, and you can use that for using the tools. Then we have APIs in Github. Those APIs are divided into 2. Firstly, we have deployment APIs, which means that those APIs or tools already have a pre-trained model included. And then there's development APIs. Those are meant for those partners who want to train the models themselves using their own data. And finally, there's also tools that have a graphical user interface. From the same website, you can access the demo site that everybody's been talking about. You can try out the different tools. And finally, and I would say most importantly, there's Tools Explorer, where we have described all the different tools that have been created in this project. And the list is really extensive. You can filter by name, functionality, there's a short description about the tool, the languages that it is available in, and also there's links to papers, to the Docker registry, to the API, and also the contact form. So you can contact the creator. And if you have a specific interest, you can obviously filter. You can say, for example, I'm only interested in summarization, I'm only interested in Latvian or Estonian, and I want it to be Dockerized. If it's available, then it will show in the table. So that's the website where you can find all the tools. Now let's get back to the presentation slide real quick. I think it was this one. Yes. So next I will show you Texta Toolkit, but before a few words about it. From an investigative journalist point of view, you can imagine, at least in Estonia lately, there were some articles about Panama Papers, where journalists did a lot of work to find out Estonians involved in those papers, and and they had to find somehow from this large data set interesting data for them. So Texta Toolkit can come handy here. You investigative journalists can browse the data sets, they can test the hypothesis, they can build aggregations to gain insight, and they can also look at the different entities that have been extracted. And under the entities, I mean persons, locations, organizations, and so on. Let's get back to this. Have to move here. So this is the Texta Toolkit, the graphical user interface for it. And let's imagine I have this data set consisting of 784,000 documents. As an investigative journalist, I'm interested in, let's say I want to find articles that are talking about Estonia. Firstly, obviously you can choose if you want to find a phrase, if you want to find a prefix, meaning prefix means that the machine suggests different word endings. We can look for exact matches and so on and so on. I do a search. I find articles, and now we only have 8,000 documents. Out of these 8,000 documents, next what I want to do is I want to build an aggregation. I want to see how these documents appear over time. But that is not enough. I also want to see what are in these specific points, the significant words that appear in these documents. And these significant words are calculated automatically. It looks at a specific snippet time and looks what are the significant words in that time compared to the rest of the documents. And as you can see that there's documents and there's some peaks here. And if you click on it, then the machine suggests that, okay, in May, there's articles about Tallinn, exhumation, monument, we buried, liberator, and so on and so on. And these words are useful for me because actually in Estonia, what happened back in that time was that Soviet monument was removed from the center of the town and there were big riots. So I go back, I add this monument to this search. I go back to aggregations and I look at the different facts that have been extracted from these documents. And if I look, for example, persons, then I can see, okay, these documents, names like Vladimir Putin, Andrus Ansip, who was back in the day the prime minister, Hitler, I'm using Sputnik as the data set here, so obviously they were hinting that we were kind of Nazi in what we did. So Hitler comes out, Lavrov comes out, and so on and so on. So as a journalist now I can say, okay, this name is coming up, and I can investigate further what's going on with this person in these data sets. Next, so this is the investigative journalist part. No, I wanted to show you this. So the second part is data scientist tool. As previously has been explained, we have created a lot of tools here in EMBEDDIA with a lot of pre-trained models, but sometimes it happens that you want to train your own models, and this can be done in the toolkit. Let's say you are a editorial chief editor, and you want your data scientist to create to automatically classify all sports-related articles, for example. So with the help of the toolkit, what the data scientist can do, he or she can prepare the training data. We can use different machine learning models. We can train models using different machine learning methods like BERT, Dodge, logistic regression, and so on and so on. We can validate these results, and we can also apply these results because we have an API. And I will now show you how this works in practice. So there's actually three different approaches how to do it. The first one is, let's say you have a ready-made data set, so with training data, so you just use that to train the model. Second option is we have included the Raccoon tool in the toolkit, and this is an unsupervised method of extracting keywords from documents. You just create the task by inputting information here about what you want to do. We want to add stop words. We say how many keywords we want to extract, and we create the task. After that, you can apply this to the whole data set. I will show you here how it's an article today in BBC, how it works. You can go here, you apply it on text, for example, and this was an article about Lewis Hamilton and Max Verstappen, and the system extracted words like Verstappen, Hamilton, Silverstone, and so on and so on. So if I apply it on the whole data set, then I can, let's say, article text. I will look for all football. And now again, I can look at the keywords that have been automatically extracted from those articles. And looking at those keywords, I can use them actually to prepare my own training data. Another approach for doing this is that we can train an embedding, and I will show how to do that as well. Training an embedding is as easy as you go to models, you go to embeddings, you create the task, say embedding, you tell the field, article, lemma test article, and that's it. You create the task, and then an embedding is trained. What is an embedding was explained to you before, but I will show you in action. Let's say you had the task of creating a classification model for sports articles. So I created a task here. I give as an entry word basketball, and I asked the system to suggest other similar words. As you can see, the system thinks maybe also volleyball, rugby, soccer, hockey, curling, handball, NBA, boxing, and so on, so on. I can save this lexicon now. If I go to back to the searcher, then I can see that if I would look just for basketball, I would find 180 documents, while if I would use the lexicon that I just created, I would have 1,200 documents, which is already quite good for training a machine learning model. So I save this as a spot, and to train a machine learning model, classical method, we go to taggers, I create the task, say spot, I want to train it on lemmatized text. I use the same data set that I just created for my task, and I create the task. That's it. And after the model is trained, you can start using it right away on your real data. And finally, what I wanted to show you, this video of, let's imagine that you have trained the model for automatically detecting offensive language. And I know quite a lot of media houses are dropping the possibility of commenting on the website, but many still post the comments on Facebook, and you can comment on Facebook. So we have created an app when, let's say I'm this Uncle Heino persona here. I went to the Texta website. There's an article about the hybrid tagger that we created. And I put a positive comment on the website. Let's say, good article, keep up the good work. Or alternatively, maybe I decide to choose really offensive language, and I post this. I won't translate it. I post this comment on the website of Texta, and now if you go to the website of Texta, what happens is I'm going to refresh it. What happens is that if you go to the article that has been published, you can see that only the positive comment is posted, and the negative one or the offensive one was automatically removed. So that's pretty much how it works in real life. And that's it from my part. Thank you very much. My name is Silver Traat, and I'm from Texta.